Hello and welcome to Set Analysis of the SASB metrics for solar technology. Today, we are unpacking a really critical, but honestly often overlooked phase of the whole renewable energy transition. We're talking about what actually happens when solar technology reaches the end of its life cycle. We'll be looking directly at the SASB standards, specifically for renewable resources and alternative energy, to figure out exactly how companies are expected to manage, measure, and report on this end-of-life management. Okay, let's dive into this.
Look, we all know that solar energy is booming globally, right? It's fantastic. But solar panels obviously don't last forever. We are staring down a looming wave of solar panel waste in the coming decades, and it's a massive logistical and environmental challenge. I mean, how do we keep literally millions of tons of glass, metal, and frankly toxic materials out of our landfills? Whether you're an investor, somebody in the industry, or just tracking the green transition, understanding how we manage this waste is absolutely critical. And to answer this, we're turning to the SASB standards, specifically looking at metrics RR-ST-410B.1 through 410B.4. This is the essential objective framework designed to track exactly how well companies are handling this inevitable crisis. So, here is our roadmap for today. We'll structure this explainer by walking right through the specific metrics laid out in the standard. We'll quickly cover 1. Fin de vie des panneaux. 2. Mesurer la recyclabilité globale. 3. Certification des déchets électroniques. 4. Les substances toxiques réglementées. And we'll finish up with the highly specific mathematical definition of 5. Le recyclage à haute valeur.
All right, Section 1, Fin de vie des panneaux, the waste crisis.
The context here is just so crucial. The incredible expansion of solar energy carries a delayed consequence, An increasing volume of these panels will very soon reach the end of their useful life. The standard explicitly flags this as a major sustainability disclosure topic. And this isn't just an environmental headache, it's a massive financial reality. In some regions, manufacturers are facing strict new legal requirements to take full financial responsibility for their products at the end of their life cycle. They actually have to pay for the collection, the take-back programs, the whole recycling process. Now, on one hand, yes, this presents a huge upfront capital cost challenge for these companies. But on the flip side, as the standard points out, it creates this incredible long-term revenue opportunity. By reclaiming those valuable materials, companies can feed them right back into their manufacturing processes and potentially lower their long-term costs.
Moving right along to Section 2, Mesurer la recyclabilité globale. Now, what's really interesting about this slide is how the SASB framework lays out a very specific set of quantitative metrics to track this exact life cycle phase. Take a look at these first two rows under Product End-of-Life Management. These are metrics RRST, 410B1 and 410B2. Notice how these aren't just vague, feel-good qualitative statements. They demand hard data. We are talking about strict percentages and actual metric tons. This kind of structure literally forces companies to be entirely transparent about their waste footprint. To really grasp what's going on here, we have to compare these two metrics side by side. Metric B.1 asks for the percentage of products sold that are recyclable or reusable. That's all about design intent, right? It measures how well the product is theoretically conceived to be diverted from a landfill. But then metric B.2 shifts us from theory to physical reality. It demands the actual weight in metric tons of end-of-life material recovered, plus the percentage that is actively recycled. It's basically the difference between a company saying, hey, our panels can be recycled in theory, and actually proving, hey, we successfully recovered 10,000 metric tons of material this year.
Section 3, Certifications des déchets électroniques. Closing the loophole.
Because here's the thing, you can't just hand your waste off to some shadow operation and claim it was recycled. The SASB standard puts incredibly strict conditions on what officially qualifies as electronic waste recycling. For e-waste to be considered officially recycled under that metric B.2 we just talked about, a company has to prove that the material was transferred to a facility holding very specific third-party certifications. The standard explicitly calls out the E-Steward standard for responsible recycling and reuse, or the R2 standard for electronic recyclers. This is a strict requirement and ensures the processing is responsible and verifiable. It basically guarantees that e-waste isn't just being quietly dumped in a landfill overseas under the convenient guise of recycling.
Section 4, Les substances toxiques réglementées. Dealing with the hazardous stuff.
This brings us to metric RRST-410B.3, which is a critical piece of the puzzle. Solar panels aren't just benign sheets of glass and aluminum. They contain hazardous materials that act as massive obstacles to the recycling process. The standard actually requires companies to track these hazardous substances by the percentage of their revenue. We're talking about substances declarable under the international IEC 62474 standard. But SASB goes even further here, explicitly calling out arsenic compounds, antimony compounds, and beryllium compounds. These are stark, severe dangers. Materials like gallium arsenide, which is commonly used in thin film technologies, require incredibly careful handling, not just during manufacturing, but crucially, during disposal.
But it's not enough for a company to just report their numbers and walk away. The standard demands narrative context. Companies have to disclose their active strategies for managing these toxic substances. They need to detail their product design criteria, like are they using banned substances lists? Are they actively conducting material substitution assessments to design the toxicity out of the product from day one? It's really about proactive risk management rather than just reactive waste management.
And finally, Section 5, le recyclage à haute valeur. So, the crucial point is
how the SASB standard actually defines success at the end of a panel's life. It is not just about shredding a panel into some low-grade aggregate. True high-value recycling operates like a strict mathematical equation. It's what the standard calls the formule du recyclage à haute valeur. Think of it like this. You need a recovery rate of 80% or greater for glass. You need 80% or greater recovery for metals. And you need 30% or greater recovery for semiconductor materials. If your recycling process doesn't hit this exact 80-80-30 threshold, well, it simply doesn't qualify as high value under this standard. This mathematical rigor is absolutely fantastic because it prevents greenwashing and sets a legitimately high technical bar for the entire industry.
So to actually achieve those strict mathematical thresholds, companies have to fundamentally rethink how they build their products in the first place. They're expected to design products specifically to meet these numbers. They have to use materials that are commonly and easily recyclable. They must design for efficient recovery, meaning the panel can actually be cost-effectively disassembled instead of just being permanently glued together. And they have to ensure proper component identification, so recyclers know exactly what they're dealing with. Plus, the standard also looks at whether these companies are participating in extended producer responsibility, or EPR, initiatives to help fund and build the very infrastructure needed to do this.
Which brings us to our final thought for this explainer. The SASB standards give us a rigorous, objective, and deeply mathematical framework for judging exactly how companies are handling their products at the end of their life cycle. As this inevitable wave of aging solar panels approaches, the pressure is well and truly on. So how will the solar industry actually adapt its manufacturing and product designs to meet these strict 80-80-30 high-value thresholds? It's a fascinating challenge, right at the intersection of environmental stewardship and pure operational efficiency. I highly encourage you to explore the SASB framework further to see for yourself how these exact metrics are shaping the future of renewable energy.